Assistant Professor, CS Department. Today we will be learning the concept of pointers. Before we learn these pointers, you should know the concept of a variable as well as the concepts of arrays. I think by this time you will be learning the both concepts like variables and arrays. So today we will see what is a pointer and different types of pointer, usage of pointers, and its introduction. Okay. So pointer is a variable which stores address of another variable. Pointer is a variable which stores address of another variable. So as I said, it is a variable. So what is a variable? Variable is a name given to some memory location. So variable is like a name given to some memory location which stores a value. See on the screen you can see what is this variable. A variable is A is a variable, it is holding value 10. Similarly, B is a variable which is holding value 40, and C is a variable which is holding value 20. And every variable will have three attributes. Say A, name of the variable, 10, value of the variable, 2000, address of the variable. So the attributes are name, value, and address. Okay. So this is a tabular representation of representing these above three variables. This is for your better convenience and understanding only. Okay, A value is 10 and B value is 40 and C value is 20. This is your memory diagram. Internally the variables will be stored in this way. A is an integer variable, so the size is 2 bytes. 2000 and 2001. 2 slots, each slot 1 byte, so 2 slots 2 bytes. Size of integer is 2 bytes. So here the variable value, A value will be stored here 10, and here B value at 2011 is B value 40, and 2007 is C value 20. This is how a variables will be declared, and this is the back end representation of creation of variables. It's like a memory location and the value in the memory location, and you are naming that memory location. Okay, and the name is variable name. So this is a pictorial representation. This is actually the memory representation. This one is memory representation. This is for better convenience, a tabular representation. So you can follow whichever thing is convenient for you. If you are okay with this back-end memory representation, you can look at here. Or if you are okay with pictorial representation, this is okay. And if you are okay with tabular way of representing a variables, you just focus on the tabular representation. So I will be teaching these three representations throughout the concept, okay, or throughout the session. So it is like a name of a memory location. Now as I said, pointer is a variable. Pointer is also a variable, but it stores address. Variable stores value, pointer will store address. Okay. So pointer is a variable whose value is address of another variable. And this is how we declare a pointer, like data type, star, and variable name. A variable name preceded with star is known as a pointer, or can be called as a pointer. Okay. This is like syntax for declaring a variable. This is a small example that demonstrates the concept of a pointer. See here. Before we see this example, let us understand how a variable and a pointer will be declared, and so that it will be easy for you to understand this thing. So you might have heard this word called pointer. Okay, pointer is something which points to. See, for example, I am pointing to a screen. I am pointing to, my finger is pointing to a mobile. My finger is pointing to nose. My finger is pointing to ears. So this is like a pointer. It is pointing to some organ in my body. Similarly, some items surrounding me. Okay. In that way, pointer is also a variable. It will point to some other variables by storing its address. See, that is what we will see in a pictorial representation from hereafter. Okay. So it is a variable which stores address of another variable. Imagine this is your code. I'll teach you this concept in form of code snippets and question and answer session. Okay. So for every example, I will be taking a code snippet. and I'll explain the code snippet in a diagrammatic way, and I'll pose you some questions. Accordingly, you need to answer that questions. Okay. See here. Say int a equal to 10. So a is holding value 10, and star p. P is a pointer. Now p equal to address a. It is an assignment operator. What am I storing here? Address. What is address of a? 2000. So diagrammatic representation, name of the variable, value of the variable, address of the variable. Similarly, name of the pointer, value in the pointer, which is address, and address of the pointer. Pointer will have address and pointer stores address. Remember this point. Pointer will have its own address and pointer will store address. So p equal to address a. So p is storing address of a, that is 2000, which means p is a pointer, it is pointing to a in that way. It's like an arrow mark. Okay, pointing to a. Now this is a pictorial way of. Now I'll show you in memory diagram point of view. So a value, a 2000 location name is a10, and 2011 location name is p. It stores address of a, which means 2011 location is storing 2000. 2000 is address of a, which means it is storing the address of a. This is how p is giving reference to a. So reference, address is also known as reference operator. Okay, it's like the way people give reference in an organization. If you want to get a job in an organization, you need to take reference of somebody, or if you are in the organization, you can give reference to somebody. So the kind of relation between those two employees, we call it as a reference relation. Here also the relation between pointer and variable is like a reference relation, which means the change in variable may affect the change in pointer also, or vice versa. Using pointers, you can change the values of a variable, or if the value and the variable changes, then the pointer referring to that value also changes. Okay, so the relation is like reference relation. Remember this point, reference. And the operator is, reference operator is ampersand. Address operator is called reference operator. Now let us see in a tabular way of representing the same thing. A is a variable which holds value 10, and p is a pointer which is holding the address of variable, that is 2000, and hence it is pointing to a. Okay, now the questions are, what is a value? If I am saying a, you need to talk value. If I am saying the name of the variable, speak value. If I am saying address and name of the variable, speak this address part. Okay, so a 10, address a 2000, p 2000, address p 2011. Okay, now what is star p? What is star p? What is p value? 2000. P value is 2000. Star p, star means data. Data at 2000. Data at 2000 is 2000 address degra data 10. So data at 2000 is 10. This is how I am indirectly accessing the value of the variable a. Directly I can get value 10 using variable name a. Indirectly I can get the same value 10 using pointer p, star p. Okay. It is, if I need to put it in Telugu, I can say pointer is like, taluka, palanavadi taluka annattu, pointer anedi. Okay. So we will go with small code snippet examples one by one, so that you can understand this concept much better. Okay. So the second example, again, a value, let a value be 10 and b value be 20, and next statement, p equal to address a, which means p is holding address of a 1000, and q is holding address of b, that is address of b is 2000. So tabular representation, a value 10 and b value 20, and p is storing address of a, which means it is pointing to a, arrow mark, and q is pointing to b, 10, and this is 1000, Address of A is 1000, address of B is 2000. Okay. Now print %d question mark, which means all these are questions you need to answer. I mean, you need to speak out the answers, right? So what is A value? You can answer these questions either by looking at the table, if you are convenient with that point of understanding, or you can answer these questions using this diagrammatic representation. Okay, whichever way is convenient for you, you can answer that questions accordingly. Now A is simply A is 10, B value 20, P means 1000. Okay, if I print an integer value P, it prints address as an integer form 1000, Q 2000, address A 1000, address B 2000, address P 3000, address Q 4000. Okay, all this you can say directly looking at the diagram itself, but these two things, star P means 1000, data at 1000 దగ్గర ఉన్న data 10. Similarly, star Q means what? 2000, data at 2000 దగ్గర ఉన్న data 20. So data at 2000 is 20. So this is how we can retrieve the data of a variables using pointers. In order to retrieve the data present in the variables using pointers, the address of that variables need to be stored in the pointers. Okay, that is what we have covered in the previous slide. Let us take one more example. Say A value is 10, B value is minus 50, and P is holding the address of A, that is 1000, and Q is holding the address of B, that is 2000. Okay, 10 and minus 50, and P is holding the address 1000, and Q is holding address 2000. This is how reference is being given to pointers. Now, after few operations, okay, after performing few executable statements, let us say I am changing the values of variables using pointers. I can change the value of variable A equal to 40, okay, but I am not using the name A. Without using variable name A, I am changing the value of A. Okay, star P. What is P? 1000. Data at 1000, which means it is referring to this location. And that value is being changed to minus 40. So before reference or before storing the address of a variable, the value in A is 10. Now using that pointer, I am changing the value in the A as minus 40. Similarly, star Q equal to 80. What is Q? 2000. Data at 2000. 2000 data or value at value or data, which both means the same. Don't get confused. Okay. Here this value star Q, I am changing that value to 80. After these two assignment operations, let us answer these four questions. Okay, what is now A value? A value is minus 40. Okay, similarly, what is B value? B value is 80. I have changed the values of A and B without using their names, but by using pointers. Okay, star P minus 40, star Q is 80. So this is how I can change the values of variables using pointers, which means you are giving your total control to a pointer. Variable is giving its total control to a pointer, so that using that address it is changing its values. Now example 3, I think it is example 4. Okay, say A value is again 10 and let B value be 20, and P is storing address of A, that is 1000, and Q is storing address of B, that is 2000. Okay, A value 10 and 20, and P is storing the address of A, pointing to it, and Q is storing the address of B pointing to it, 2000. Okay, but the statement here is I haven't declared any Q pointer, so there is nothing like Q here. I'm sorry, there is nothing like Q. There is a P only. Okay, two variables, one pointer. So initial A value is 10 and B value is 20, and P is storing address of A. P is storing address of A. Now what is A value? 10. Address A, 1000. P value, 1000. Address P, 3000. Star P, P is 1000, data at 1000 is 10. After few executable statements, let us say now pointer is pointing to B, which means before this statement P is pointing to A. Now P equal to address B, P is storing address of B. It is changing its pointer location to B by storing the address of B. Okay, previously it is pointing to A. Now this pointer is pointing to B. You can see this, right? P. Previously it is pointing to A. Star P value is 10. Now it is pointing to B. Star P value will be 20. So it is like a pointer. It can point to any variable. Just like a pointer in your speedometer. If you are traveling by bikes, you can see that pointer, 30 kilometers per hour, 40 kilometers per hour. It's like a pointer. It points to some variable. Okay. So a pointer refers to a single variable at any point of time. A pointer refers to a single variable at any point of time. Now imagine there is only one variable and two pointers. Previous example, two variables, one pointer, or many variables, single pointer. Now one variable, two pointers. Example 5. Now let A value be again 10. There is nothing like B, and P value be address of A, that is 1000, and Q is also storing address of A, 1000, which means there are two pointers pointing to a single variable. P is storing address of A, 1000, and Q is also storing address of A, 1000, which means both are pointing to same memory location. Okay. Now what is A value? 10. What is star P value? 10. What is star Q value? Is also 10. So what if I change the value of A using star Q equal to minus 150. Initially it is a positive value. After few executable statements, say the value of star Q has been changed to minus 150. Q is 1000, data at 1000 is minus 150. Minus 150. So now what will the value of A? Minus 150. What will be the value of Q? Minus 150. Sorry, star Q, minus 150. What will be the value of star P? Minus 150. Because all these are pointing to same memory location, this one. Okay. P is pointing to 1000 and Q is also pointing to 1000. So at the end of this example, the conclusion is a variable can be referred by any number of pointers. A single variable can be referred by any number of pointers, but the change in that variable will affect the change in remaining pointer variables also, or the change in pointers will also reflect the value in the variable. So this is something we need to be very cautious when we give address of a single variable to multiple pointers. Okay, because the change reflects in remaining pointers also. Whereas the case of previous example, that is not the case. Previous example is like, there are two variables and one pointer. A pointer can refer to a single variable at any point of time. It's like changing its decision towards the pointer. Okay. Now, so this is a very short introduction about pointers. I have covered the definition of pointers, declaration of pointers, advantages, disadvantages, and its way of representation, the memory representations, and how do you retrieve the values, how do you change the values using pointers, and how single variable and multiple variables acts on the will be acting each other. And okay, now we will see the sizes of pointers. Before we get into the sizes of pointer, let us take a quick recap on unit number 1. Like, there we will be learning the data types in C language. Primarily we will be focusing on 4 different data types in C language, like, character, integer, float, and double. The size of character is, so here I will be writing, okay, the size of character variable is 1 byte. All these things, right? Character variable 1 byte, and size of integer variable a is 2 bytes. Similarly, size of float variable b is 4 bytes, and size of double variable d is 8 bytes. I am talking these sizes with respect to C89 standard. If it is like C99 standard, latest versions, like you can take size of integer as 4 bytes. So like your online compilers, there you can see size of integer as 4 bytes because it follows C99 standard. But ANSI C, our syllabus is based on ANSI C. There you will have size of integer as only 2 bytes. Okay, this is a small correction and then now this data types is fine. Now p is an integer pointer. P is a integer pointer. What will be the size of integer pointer? Similarly, q is a pointer, float pointer, size of q. R is a character pointer, S is a double pointer. So what could be the sizes of P, Q, and RS? Okay, so the size of pointer is not dependent on data type. The size of pointer is always 2 bytes irrespective of data type. So no matter what the data type is, the size of pointer is always size of integer, because pointer stores integer and integer is always 2 bytes. Okay, so whether it is P, Q, R or S, the size is 2 bytes. Okay, no matter character or any pointer. If it is a pointer, it stores address. Address is integer, size of integer 2 bytes. Simple explanation. Star P. So what could be the star P? P is, it is referring to, say P is referring to A. So data at A, size of data at A is 2 bytes in that way. Okay, this is like 2 bytes, again 4 bytes, R is 1 byte, and S will be 8 bytes, provided if P is referring to A and Q is referring to B and R is referring to character variable and S is referring to double variable. So the conclusion at the end of the slide is the size of pointer is always size of integer, which is 2 bytes, no matter what the data type is or irrespective of data type. Okay, now here we will see multiple data types. Multiple data types with respect to pointers, and say A is an integer variable, B is a float variable. A is a integer variable, B is a float variable. Now slowly I am getting into this kind of representation, tabular representation. Okay, initially I taught you 3 types of representation. Finally we have reached to this tabular representation only. So A is holding value 10. Okay, and B is a float variable which is holding value 98.6, and P is an integer pointer, Q is a float pointer. Okay, imagine this case, P equal to address A and Q equal to address B. P equal to address A and Q equal to address B. Now what is A value 10, B value 98.6, address A 1000, address B 2000, P is address A, that is 1000, and Q is address B 2000. Okay, star B is 10 and star Q is 98.6. Star B is 10 and star Q is 98.6. Fine. There is no problem, and this is simply pointer and variable concept. This is what we have been learning for the last 10 to 15 minutes. Now, what if this case, sir, as you said, address is an integer, address B is an integer. Can I store that address B in P? Because P holds integer, P holds address, which is an integer. Address A is an integer, Q holds an integer, which is an address. Okay, so can I store in this way, or if I need to put it in a sentence, can I give reference to can an integer pointer give reference to a float variable, or can a float variable or float pointer give reference to a integer variable? So P is an integer pointer giving reference to float variable. Q is a float variable giving reference to integer variable. Is it possible? Pictorially it looks like possible, or logically it looks like possible, because at the end of the day it is storing its address. Okay, it is not storing the values, but technically it is not possible. Technically the size of though the sizes of pointers are 2 bytes and it stores integers, it can't give reference to its other variables. I mean to say, the data type of pointer should be same as data type of variable. Integer pointer can give reference to only an integer variable. It can't refer another variables. So this is possible, but this is not possible. P equal to address B is not possible. This is not possible. P equal to address B is not possible. Similarly, Q equal to address A is not possible. Q equal to address A is not possible, because the data types are different. So at the end of this slide, you should know that in order to give reference, the data type of pointer should be same as data type of variable. Okay. So this will generate errors. And next slide. Before we go to next slide, we'll see different types of pointers. Like null pointer. Null pointer is a pointer which is storing value null. It is like int star p equal to null. If a pointer is assigned with null, we call it as a null pointer. Null means nothing, not even 0. Null means nothing. If a pointer has been declared but not assigned any value, which means it stores some garbage value or garbage address, such pointers are called wild pointers. A pointer that stores some garbage address, or it is pointing to some unknown location. It is pointing to some unknown location. There is a location it is pointing to, but I don't know what data is there in that location. That pointers are called wild pointers. Or simply you can say, if a pointer is declared but not used yet, all local declaration pointers are wild pointers if not initialized. Okay. And void pointer. Void pointer is a pointer which gives reference to any data type variable, or it refers to any data type variable. Because in previous slide, as I said, in order to give reference, the data type of pointer and data type of variable should be same. So say imagine there is a data type like integer. Integer pointer refers to integer variable. Similarly, float pointer refers to float variable. Character pointer refers to character variable. Or double pointer refers to double variable. And there is also a data type called void. So do we have a void variable? No. Void means nothing. 0 bytes. Okay. Name of 0 bytes. Sounds nonsense, right? Name of 0 bytes. If the bytes are 0, how can you name that memory location? So there is nothing like void variable. So there are no void variables, but there is a void pointer. So void pointer should point to void variable, but there is no void variable. Okay. So void pointer will refer to any data type variable. Void pointer refers to any data type variable. Like a void pointer can give reference to an integer variable, it can give reference to a float variable, it can give reference to a character variable, it can give reference to double variable or any data type variable. Hence it is called generic pointer. Generic is like root word of general. Okay, we will call in trains we call it as general bogie, right? Anybody can get into. Similarly, a generic pointer, it refers to any variable, but there is some constraint. In order to give reference, there should be typecasting. There should be explicit typecasting. You might have learned this concept of explicit typecasting in unit number 1. Using explicit typecasting only, you can give reference to a void pointer. or a void pointer can refer to another variable using explicit typecasting only. And there are other pointers like far pointer and near pointer. These things, let me explain what is this far pointer and near pointer in next slide. Okay. I'll explain this far pointer and near pointer in further sessions, because I need to explain the concept of segments, segment address, offset address. Using that concept, I can teach you that particular thing. But as of now, I'm skipping these two topics for the next session. Now, let's get into this programming part. How to add two numbers using pointers, or there are different ways of performing addition between two pointers. Addition between two numbers using pointers. So, pictorial representation, say a value is 10 and b is 20 and c is a variable with some garbage value. No value has been assigned to c, hoping these variables are local variables, and this is, it's like a garbage value. Now, PQRR pointers, P is storing its address of A and Q is storing address of B and R is storing address of C, which means P refers to A, Q refers to B, and R refers to C. This is a simple arithmetic operation you might have learned in unit number 1, addition of two numbers. Like A value 10 and B value 20, 10 plus 20 will be 30, assigned to C, 30. Problem solved using variables. But the same thing I'll teach you using pointers. There is like direct way and indirect way of accessing thing. A 10. Direct ga a value తీసుకొస్తున్నాను 10, or the value in A is 10. Similarly, the value in B is 20 directly. Indirect way of accessing the same 10 value is star P. P is 1000, data at 1000 is 10. So star P refers to same memory location. A also refers to same memory location. It's like a same memory location has got two names. Okay. The original name is like, A, and it's like a nickname is like star P. Okay, two names. It's not a nickname, it's like reference name. Fine. Now, there is other way of performing the same operation. C equal to star P plus star Q. Star P, indirect way of getting A value, 10. Star Q, indirect way of getting B value, 20. 10 plus 20 is 30. Directly I am storing in C. The star R equal to star P plus B. Star P, indirect way of getting A value, B is directly getting B value, 10 and 20. And you are storing the 30 indirectly in C. Star R, which is this location. Star R, R is 3000. Data at 3000 is C, this location. Okay. Now, next question. Star R equal to A plus star Q. A is directly you are accessing value, and star Q is indirectly you are accessing B value. 10 and 20, 30, or indirectly storing value in C. Star R equal to A plus B. A directly 10, B directly 20. Performing addition 10 plus 20. You're storing the 30 indirectly in C using pointer. And in all these cases, at somewhere at some point of time I am using these variables at least once. Right, I am using variable at least once. Here completely variables. Here one variable. Here there is one variable. Here there is one variable. Here there is one variable. And this case is no variables involved. All pointers only. So star P indirectly A value, star Q indirectly B value, and you are performing 10 and 20 and storing the value in C, 30. Okay. So nowhere you have used the names of variables A, B, C. Without using the names of variables, you are changing the values of variables, or you are accessing the values of variables using pointers. Okay. So all these are different questions that you need to answer. These are different, multiple choice questions wherein we will be asking like a code snippet, and we'll ask you to predict the answer, okay, or predict the output. For that, you need to do some, diagrammatic work to understand these concepts and all these things. Fine. Now let us see the advantage of pointers. You can make a short readout of this advantage of pointers. Like pointers provide direct access to the memory. Pointers provide a way to return more than one value to the functions. reduces the storage space and complexity of the program, reduces execution time of the program. We will see all these examples in further all these explanation as an examples in further slides. Okay, like call by reference, call by value, dynamic memory allocation. And in data structures, we will be using this concept of pointers in linked list, stacks, queues, and trees, and graphs, etc. There is a concept called dynamic memory allocation and self-referential pointers. Using these two concepts like dynamic memory allocation and self-referential pointers, we will use these concepts in subject called data structures. So data structures is all about pointers concept and pointers and structures. Okay, you can have a short readout of this. Disadvantage, as I said, you can change the values of variables using the pointers. So there are some explicit problems like there are chances of changing the values of variables unknowingly. Or see this example. I'll get back to this example. Multiple pointers referring to a single variable. Okay, this is one disadvantage. Say there are 5 pointers pointing to a single variable. So the change in variable will affect change in all 5 pointers, right? Or the change in one pointer will affect change in remaining 4 pointers as well as the variable. And pointers are slower compared to normal variables because variable is name given to memory location, direct way of getting the value. Pointer is like indirect way. You need to perform some calculation part. Like star P is 1000, data at 1000, and again you need to move to 1000 location and get the data, which is a time consuming part. Okay, and using pointers you can easily corrupt the data, and there are a lot of security issues with respect to pointers. Hence this concept has been eliminated in further programming languages, especially in object oriented programming languages. The concept of pointers has been eliminated, especially Java. We don't have any pointers. Okay, now we will see a few examples. The topic of this slide is like pointer arithmetic. All these are questions and you need to answer accordingly. I'll give explanation also. Okay. Now say A value is 20 and B value is 40 and C is 90 and P, Q, R are pointers. This is a variables table and this is a pointers table. Okay. The content that is in red color here, address doesn't change and address is like system dependent. Address will be assigned by the system. It is not assigned by the user. Wherever the memory space is free, there the memory will be allocated with the allocated and name will be given to that allocated memory. So this is system dependent. Okay. C, P equal to address A, Q equal to address B. Accordingly, I gave address of C is like 3000. R is referring to C. Q is referring to B. All are integer pointers, so no issues. Fine. Now C equal to A plus B, it's like 20 plus 40 is 60. Question number 2. C equal to star P plus B. Star P is indirect way of getting A value 20 and B is 40. Same. Star R equal to C plus star Q. C is 90 plus star Q. Star Q is 40. 90 plus 40 is 130. 130 is stored where? Address of star R. R is 3000, data at 3000. This is 90. Question number 3. Okay, question number 4. Star P plus star Q. Star P is 20, star Q is 40, 40 plus 20 is 60, star R 60. Question number 4. Next question number 5. C equal to P plus Q. What is P? 8000. Q 4500. 8000 plus 4500. It's not a syntax error. Sir, P is a pointer. You need to use pointer using asterisk only. But here you are using P plus Q. It is not the case. And P holds value as 8000. That 8000 is an address. Okay. So P's value is an address. I mean to say that. Q's value is an address which is 4500. Now P plus Q is 12500. 12500 is stored in C. So here you will be getting a warning but not an error, which means it gives you warning like 12500 is an address you're storing that address in a variable. Okay, are you sure? It shows a warning. And for time being, I'm making these calculations as a decimal number system only, but addresses are like hexadecimal number system. So 8000 plus 4500 will be some hexadecimal value. So hexadecimal number system, I'm converting it like decimal number system for time being only. So this is stored in variable. It is not an error, it is a warning. And see this case, p plus q, again 8000 plus 4500 has been stored in star r. R is 3000, data at 3000, 12500. These two statements are same. Okay, this is directly and this is indirectly. So far all green color questions has been answered. Now let us see this capital letter alphabets questions. Okay, this part. A plus b in R, A is 20 and B is 40. 20 plus 40 is 60. Where am I storing that 60? R, here. Again it shows a warning, not an error. Which means R is storing 60. It is referring to 60th slot in the memory location. As I said, this one, address 60th slot from 0000 to 9999 decimal number system. Here it is referring to. It gives warning like you are referring to some 60th location. You don't know what value is there in that 60th location. Are you sure you are referring to that location? It shows a warning on that. It's not an error. Okay. So R equal to A plus B. 60 stores here as an address. 60 is like an address. 20 plus 40 are values. Okay. Value plus value. That value is stored in a pointer. So pointer will treat that value as an address. Okay, that's the point there. Now R equal to star P plus A. What is star P? 20. And A is 20 again. Star P is indirect way of getting A, 20. And A is 20. 20 plus 20, 40. 40 is stored in R. R is referring to 40th address location. In that 40th address location, there will be some garbage value. Next question, star P plus star Q. Indirect way of getting A and B values, 20 plus 40 and is referring to 60. Again, it will show you warning but not error. Now, take the case D. P plus Q. What is P? 8000. Q, 4500. Total, 12500. I am giving that 12500 to R. This is error. Because addition between two pointers is not possible. You are adding two addresses. So our mathematics fundamentals says like if you add any two numbers, the result will be greater than that two numbers. Right? Add any two numbers, the result of that addition operation will be greater than the two numbers. Similarly, if you add any two addresses, the result of that addresses will be greater than that address. That address may exceed the memory location or segment address. Like here imagine the beginning address is 0000 and the ending address is 9999. Okay, and I'm adding the two addresses 8000 plus 4500 and the address is 12500, which is out of memory. The limit of is 0000 to 9999 only, but this address is out of memory. R is referring to something out of memory. We call this as segmentation fault. It is an error, not a warning. Previous three cases are like warnings, but this D is like error. You can't perform addition between two numbers, two pointers, not numbers, two pointers. Now subtraction. Yes, you can perform subtraction between two pointers. 8000 minus 4500, which is 3500. It will store that 3500 and refer to that 3500. No problem, because again the mathematics fundamentals says the subtraction of two numbers, the result will be less than the two numbers, one among the two numbers, not less than the two numbers, one among the two numbers. Say A value is 15 and B value is 6. 15 minus 6, 9, right? So 9 is less than one among the numbers, 15 or 6. So the address will be within the scope only. The result of that address will be within the segment scope only. So it is not an error. Addition error, and this is also error. addition కుదరలేదు, multiplication, it will exceed the memory location. Okay, division is possible. Again, if you divide any two numbers, the quotient will be less than either divisor or dividend. Okay, which means within the memory scope only, it will point to that memory location. So looking at these four statements, you will understand that you can perform subtraction between two pointers, you can perform division between two pointers, you can perform modulus between two pointers. Okay, because the result of the subtraction, division and modulus is less than the any of the given two input values, any of the given values like P and Q. Hence it will be within the limits of, within the scope of memory only. But addition and multiplication will exceed the memory locations, or there is a chance of exceeding the memory location. Hence the addition and multiplication is not supported for pointers, and this concept is called pointer arithmetic. You cannot add or multiply using pointers. You cannot perform addition and multiplication on pointers, on pointer addresses. Okay, that's the point here. Next one is P plus plus and P minus minus. So what is P value? 8000. P plus plus, as you know, plus plus is an increment operator, it increases by 1. But with respect to pointers, increment operator increases by one slot. Okay, like the data type of pointer P is integer. If it is P plus plus, it refers to next slot 8002. P holds value 8000, P plus plus means 8002, next slot. 8000 and 8001 are integers, right? P minus minus, it refers to previous slot, it doesn't increases by 1. If it is a case of variables, the values would be like 8001, P plus plus means 8001. But here, since P and Q are pointers, P plus plus means next slot address, that is 8000. This you can see using the concept of pointers and arrays. There I will teach you with much better explanation with these increment and decrement operators. Next we will see these questions like performing some integer values, or you can try these questions by yourself. You try to execute a small code snippets and get output for yourself. Pointer to arrays. So this will be our next session, pointer to arrays.